All right, welcome to Schroeder Academy. Today we're going to do Chapter 10, Section 3, which is applying the properties of chords. So we're moving from angles and arcs and stuff to just some different properties with chords that mix in those arcs and things like that. So remember postulate theorem sheet like usual. First we need to highlight theorem 10.3, which says that in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So congruent circles are in the same circle. All right, arcs are congruent. Arcs are congruent if their chords are congruent. So if these two chords are congruent here and here, that means this chord is congruent to this chord. That means that this arc's measure in degrees is the same as this arc's measured in degrees. So if this is 70 degrees, this would have to be 70 degrees because the two chords they're just going to cut the equal parts of the circle off. Okay? And our next two theorems, it says if one chord is perpendicular bisector of another chord, then the first chord is the diameter. So what it's telling us here is that if this chord right here, SQ, is perpendicular and bisects, then SQ is a diameter. That's important. We're going to use that in a theorem to do a bunch of work. I'm going to teach you something that I developed that I've invented. So I've actually invented something that's kind of cool. The next one is if a diameter of a circle is perpendicular to a chord, then the diameter also bisects the chord in its arc. So what this one says is that if this is a diameter and it's at a right angle to a chord, then this arc and this arc are congruent, but it also bisects that chord. That again is also important. These two kind of go together. One of them tells you that it's a diameter. The other one says you have a diameter and it bisects it. So they do two different things. They're not exactly converses of each other, but they do kind of the reverse information of each other. We're going to learn to use both of those. All right, so if we look here at a few practice examples, it says find the measure of the red arc or the chord in circle C. So again, if we look at this chord is congruent to this chord. And this is the center of the circles here, and this is a 75-degree angle. This is a 75-degree arc, and therefore this is a 75-degree arc. And so, oops, didn't mean to write that red line there. So I can move this down here. So therefore that red arc there is 75 degrees. If we look over here, we notice that we have this chord and this chord being the same length. If they're the same length, that means this arc here and this arc here are the same length. But we don't know what either one of those arcs are. But we do know a whole circle is 360 degrees. And we do know we have a 128-degree chord there. And so I get 232 left for two chords, or two arcs. Well, if I got two arcs, I'm going to divide that by 2, and I get 116 as each arc. So this is 116, and therefore this is 116. And so that's where we get our answer of 116 degrees for the arc of AB. Now, if we look at this picture, this number 5 one, notice there's a right angle here, and this is a diameter. And we learned that theorem just a minute ago. It says if you have a right angle and a diameter, then this is bisected. And so therefore, G is 8. And the whole thing, which I could ask at times, would have been 16. So whole chord 16, each part is 8. Remember that we also know that arc GH is congruent to arc JH. Remember, because it also bisects each one of those two arcs also. Okay? All right, so we're just practicing applying that. So we're going to do that a lot in homework. Here's one more little theorem that we have to cover, which says that in the same circles or in congruent circles, we do a lot of same circles, but it works in congruent circles. If two chords are congruent, if and only if they are equidistant from the center of a circle. So what it says these two chords here are congruent as long as the distance from F to E and G to E are congruent. If those are congruent, then those two chords have to be the same length. All right, and so if I knew the two chords were the same length away from there, then I know the two chords would have to be congruent. And by the way, that's also a right angle. Couldn't I extend this and make that a diameter? Which means then that these would be bisected, which is another thing that comes out. It means that also that we could bisect the arc if we put a whole entire diameter in there too. All right, so let's do some application. So I'm going to do the first one, and you can work on the second one, or you could pause the video and try both of these. So that might be a good idea. Pause the video, try them, and then turn back when you're ready to see the solutions. All right, as we look at this problem here, notice that we have a diameter, we have a right angle, and we know if you have a diameter and right angle that these two have to be congruent. So then I have 5x minus 6 equals 2x plus 9, and you should be able to solve that for x. We get 3x equals 15, x is equal to 5. Remember that I could even ask something like, what's the length of the whole arc or something like that, so you should be able to solve something like that also. So then we're using theorem 10.5, which is that a diameter perpendicular to a chord bisects the chord. Over here, this one, we have equal distances away from the center of the circle, so this piece and this piece are equal, so we know those two chords have to be the same, so 5x minus 7 equals 18, so 5x equals 25, x is equal to 5. How we know this? We know that because of theorem 10.6, which said that if two chords are equidistant from the center of the circle, then they are also congruent. The chords are congruent. All right. So this one says, can you conclude about the diagram shown? State a theorem that justifies your answer. So what can we look at this picture and say? Okay, we already know this right angle, we already know this bisected. But do we know if AB is a diameter? And so you should be able to say yes, because we had that theorem 10.4, which said that if it's perpendicular and bisects, then it must be a diameter. All right, if we look at this one, we have a right angle, we have a diameter marked in here, so we should know that this chord is bisected. So JH bisects it, so we know that this piece here is congruent to this piece. Now we can't exactly name them because we don't have that point of intersection to name it. But we also know that this whole arc here is also bisected. All right, last one. If these two are congruent from the center, then we know that this whole chord here, NP, is congruent to LM. And that was theorem 10.6. So just a little practice on those theorems. All right, so here's the stuff that I'm going to teach you that I developed and learned. It says, suppose the chord of a circle is 14 inches long and is 24 inches from the center of the circle. Find the length of the radius of the circle. So pause the video, see if you can draw this picture, and then turn the video on when you're ready to see how it looks. Okay, so to draw this picture, this is an awesome problem. I created this thing called the Schroeder 4 many years ago, and it's kind of a really neat thing. So let's start with a circle here. So there's our circle. All right, so you should have a circle in your paper. Remember I told you start having a quarter. It might help you to draw pictures. And there's a center dot right here. So the Schroeder 4 is not like the Fantastic Four. If you know anything about comic books and stuff, like the Fantastic Four looks like this. You know, Mr. Flame goes up and flies and does that little Fantastic Four thing. The Schroeder 4 is a little shorter, I guess. And it starts here, goes to the center, and we do a 4 right down here. And this is this is a Schroeder 4. Okay, so for the Schroeder 4, here's what you need to understand about it. This is the radius. It goes from the center to the edge of the circle. This piece right here, that is the chord. And this piece right here, and so I'm going to mark that piece in red, from here to here, is a chord's distance from center. And so then once I have that information, I'm going to redraw this in here again. I'm going to do another Schroeder 4 here. It says here, suppose the chord of a circle is 14 inches long. So from here to here is 14 inches. And is 24 inches from the center. So this is 24 inches. Now let me remind you of a few things. Back here at the Schroeder 4, that this can be considered a diameter, and if it's a diameter, it's going to be perpendicular and bisects that chord. So that means we have a right angle here, and we bisect it, so that means this is 7 and this is 7, and this is what we're looking for. If you know your Pythagorean triples, 7 blank, well, not blank there, 7 24, excuse me, blank, because that's our hypotenuse. And so therefore you should know that the radius will be 25 inches because of our Pythagorean triple. Or you can put in Pythagorean theorem, 7 squared plus 24 squared equals r squared instead of c squared. And there you have a problem. So pause the video, work this one. There's also another one after that, but you won't be able to see that one because you're going to pause the video and then pause the video for the next one also. All right. Okay, so now that you've had a chance to work out this problem, let's go do the Schroeder 4. So there's our 4. It says suppose a chord of a circle is 40 centimeters from the center. So this is a 40 with a radius of 41. And it says what is the length of the chord? So what we're looking for this time is this value right here. Now remember that we have a right angle and these are congruent. So let's look here. We have a blank, comma 40, comma 41. That might be a Pythagorean triple. If not, you can put a Pythagorean theorem and work. What we find out is that missing value is 9. So this other missing value is 9. So therefore the chord is 18 centimeters long. There's our answer. Okay, and so now here's our last example. Pause the video, work this one, see if you can get this one right. For this one, you should have gotten the answer, 9 feet. To watch it work, go to our Schroeder 4. And it said our radius is 15. It said our chord is 24, so from here to here is 24, which means that's 12. That's 12. This is random value, so 12, comma blank, comma 15. See if it's some sort of triple. I divide both those by 3. I get 4 here, and I get a 5 here. Oh, that must be a 3. And so 3 times 3 makes that the 9 that we were looking for. All right, and so your assignment will be to work pages 5 and 8 through 9 for Monday. Thank you.